Okay, so today it is about probability, and there's all different kinds of probability ways you can solve problems. Think of it as tools that you can pull out when you need to answer a problem. It's kind of like you're a workman who comes across this problem, and you're like, sometimes a hammer is better to solve the problem, and sometimes a saw is better to solve the problem. How would you solve this one? And tell me, like, in terms of like, oh, I'd use blanks, or I'd use CC over C, or I'd use maybe the C with the two parentheses after it. All right. I tell you that I am an 80% free throw shooter, and at the end of the game, I get a chance to shoot 5 free throws. What's the probability I make 5 out of 5? If I have an 80%, actually I should make it 4 out of 5, because otherwise there's an easy way to do it. 4 out of 5 shots, given that I'm an 80% free throw shooter. Again, 4 out of 5 is 80%. So it seems like I'm saying, what's the probability I shoot 80% if I'm an 80% free throw shooter? And the probability is not 100. It seems like it should be. The question is, if I'm an 80% shooter, what's the probability I'm going to make 4 out of 5 at the end of the game when it matters? Now, there's a way to do this with a tree, but it would take you approximately an hour and a half. So don't use a tree. Yes.
Is it exactly 4 out of 5 or at least 4?
Good question. I said 4 out of 5. If I had said at least 4 out of 5, you would have had to do 4 out of 5 and 5 out of 5 and then add them together. But I didn't. I just said probability of 4 out of 5 being made. Sir, you got a question or an answer? All right, hold on just a second. A lot of people are still calculating. And if you haven't already, get your graphing calculator out. You'll need it. A lot of these answers are decimals. If you want to borrow one from me, you may. I'll pause for a second while you get some stuff ready. All right, so Miss RR is telling me the answer. She said I should do 5C4 and then 0.8 to the fourth, 0.2 to the first. And you can tell if you're doing this right, kind of at least, by making sure that this is right there and that these two add up to 5. All right, and you have done it correctly. That is the probability that I will get 4 makes and 1 miss. This tells me how many different, if I had done a tree diagram, how many different routes would be like that. And that's why you have to multiply by that, because there might be 5 routes that would have 4.8s and 1.2. When you multiply that all out, who's got that answer? What did you say? 4096. Raise your hand if you concur. Okay, good. So that's about a 40% chance. Why is there, oh, okay, we're on to 41, you're right. So why is it only a 41% chance? If I'm an 80% free throw shooter, shouldn't I make 4 out of 5? Isn't that like 80%? Yeah, but I might do what? I might get below or above it. I might get 5 out of 5, and I might get 3 out of 5. And I might, if I'm really having a bad day, only get 2 out of 5, and there's probabilities for each of those things. Okay, so what about the same kind of thing, except what if I say, what's the probability I'll make at least 1? Then do you get, I'm really saying 1 or 2 or 3 or 4 or 5? But that is really slow to have to figure out each one of those and add them all up. So when I say at least 1, do you get that's the exact same thing as saying not 0? If I say I'm going to make at least 1 shot, that's saying the exact same thing as I'm going to not make 0. Okay, so what does not mean? Not means 1 minus whatever you were going to say. Like, let's say there's a 40% chance of rain today. What's the chance of not rain? Which is because you do 1 minus 0.4. And that's where you get the 0.6. Not means 1 minus that thing. So if I say I'm going to make at least 1 shot, that means I'm saying not 1 minus. Going to make 0. 5C0. Does that make sense to you? 1 minus that. If I say at least 1, that means not 0. Okay, what if I said, I mean, the reality is you want people to, if it's on your team, to make at least 2 out of the 3 shots or whatever. Okay, so let's do one like that. Let's say that I'm still an 80% free throw shooter and I get 3 shots at the end of the game. And if I get at least 2, we win. At least 2. What's the probability I'll make at least 2 out of my 3 shots? You really can't do this with not. You can, but you have to subtract 2 things, in which case it's actually slower than just figuring out the probability of making at least 2, meaning 2 or 3. Except you have to do 1 minus it. I know it's close. You can do it that way if you want. The other way, where it's at least 1, then it's a clear winner. Much faster to go not 0. So the question here was probability I'll make at least 2 out of 3. That's not a 3. 3. Okay. Then you should have done C, and I got 3 shots and I make at least 2, so that's 2. Most common mistake answer is to just do 2. But that would win for me, or I might make 3C3, 0.80 to the 3.20 to the 0. You find this answer, you find that answer, and have you been trained enough that or means add? I hope so. When you see or, you should be thinking add. How about this? In probability, when I say choices, you should think of a function. What do you do with choices? I'll give you a hint. In the blank problems, you always have a bunch of choices. What do you always do to choices? You multiply your choices. All right, so here's the simplest of all probability type questions then. Oh, by the way, what was the answer for that one? 896. Raise your hand if you have the same thing. All right, good. 0.896. That's about a 90% chance that I'm going to make at least 2 out of 3, and that makes sense. Okay, so now let's move to the blanks kind of questions. So let's say, oh, question?
I thought we had our final probability, so why would this be on the final?
The probability final is, the probability is on the final, but what you're thinking of is we had a big probability test which could count as a retake for the 2 smaller probability tests. But that wasn't the final. So probability is on the final, and you can use your final as a retake of the big probability test, because the big one you never got a chance to retake. All right? So, and that'll be, because remember how this final is divided into 2 parts, the 3rd quarter and the 4th quarter? The 4th quarter is the quarter where you haven't had a chance to use a retake yet. That's where, if you do well on the 4th quarter part, we'll tell you which part that is. And if you're done with it and you feel like, I feel good about this, I'd rather replace my C I had before with this final, you can do that as long as you have done the corrections for that test. So if you have any really low grades, it's just smart to do the corrections ahead of time. Besides, it'll help you get ready for the final. So you can still do that all the way right up till the final. But as far as turning in late work, one last thought on that. Yeah, last day to turn in late work is on Monday. So if you have any late work, it's in by Monday, otherwise it doesn't go in. Okay? In class on Monday. All right, so with blanks, here's an example where you'd multiply choices. One of the easier probability questions would be, let's say that there's a license plate that has 2 letters. These are letters. And these are digits, like numbers. They can be 1 or 0 through 9. So these aren't 2-digit numbers, they're single digits numbers. How many are there? Good question. Can you repeat? Let's assume for a moment that you cannot repeat digits. That'll make the problem a little bit more challenging. If you can't repeat things, like you can't have LL, as long as they're different, it's okay. And remember, blanks are about choices. How many choices do we have for this first spot? There's 26 letters out there. And since we can't repeat the one we just chose, 25, and then this would be 10, and this would be 9. Raise your hand if you had that one right. Okay, good. Now, let's change it to blanks in a different scenario. There are 4 books on a shelf. How many different ways can you arrange them? That's a good question, but they won't tell you whether the order matters or not, but they told you by how they asked the question. Think about this. There's 4 books on the shelf. If the order doesn't matter, is there any point to the question? No. So that assumes that the order matters. You can do it with blanks. You can do it with a C or a P, because if you choose the right one, because either way works. Like different tools in the bag. So I personally would like to use blanks, and I'd use 4 times 3 times 2 times 1. And why am I not doing 4, 4, 4, and 4? Can't any book go in any spot? Yeah, but once you've chosen a book for this spot, it can't also be here, and therefore it has to go down. What would have worked if you decided to go with a P on this one? 4P4. And that was 4 books, and I'm going to care that the order matters, the order patters, remember, and then the 4 is also how many books I'm choosing to take in my groups. I have 4 books, I'm going to choose all 4 of them and put them out on the shelf. 4P4 will be the exact same thing. And yes, there is a way to do this with factorials. It's just that there's a formula for the P. Your calculator does it kind of behind the scenes. If you remember where that is, it's under math on the calculator. And we can do this one, of course, in our head. 4 times 2 is 12, times 2 is 24. I'm just reminding you that the calculator can do this. But what it is doing is it is setting up a 4 factorial. Actually, this is a terrible one because both of these numbers are the same. So I'm going to do a simpler one. Can you remember how to do 5P3 with factorials? That kind of thing. And what that means is, for instance, I have 5 people in a race, and I have places for first, second, and third. So only the first 3 do I care about. And the order does matter because it's a race, as opposed to just I'm picking 3 people to help me sweep up the floor. It wouldn't matter, the order. Okay, should add 5 factorial over 5 minus 3 factorial, which of course is the same as 2 factorial. Is there anything more to it? No. If you threw in an extra 3 factorial, you're thinking of not the P, that would be if you were doing the C. If I did 5C3, it would be 5 factorial over 5 minus 3 is 2 factorial with an extra one of those. Ring a bell? Okay. Next, let's talk about where else you use those C's. One of the strategies is CC over C. This is a probability question where you have the big group is on the bottom, and the subgroups are on the top. Okay, so let's do one where we have 5 cards dealt. And I give you 5 cards, and I give you 5 cards, and I give you 5 cards, and I give you 5 cards. Okay, what's the probability that a kid, the kid we're focusing on, gets all hearts? Try to remember how to set this up. The big numbers go on the bottom. The smaller numbers, the subgroups, go on top. And you're going to get 5 cards, and then what's the probability you'll get all hearts? That would be called a heart flush. I'll pause for a second. Let me try that one. Okay, let's see if you did this one right. You should have been thinking there's 52 in the big group of cards, and I'm choosing out 5. Raise your hand if you had that part right. Good. And the next part is, if I just want only hearts, there's still 2 subgroups. There's hearts, which there's 13 of, and there's not hearts, which there's how many of? 39. Good. And then the hearts, I wanted all 5 to be hearts. So this is a 5, and that's a 0. You don't have to have this part, but it's smart because that way, when you do that plus that, it equals that. And you can kind of check yourself by making sure that plus that equals that. Raise your hand if you had that one right. Good. That's a really powerful strategy because it doesn't just work for cards. You also do this kind of thing on pizza problems. You also do this. Remember how it's got a C's in it, and therefore order has to not matter. You get on a pizza or on a sub sandwich or whatever, the order doesn't really matter. Ooh, you put the ham before the potatoes, or no, you don't put the potatoes in the sandwich. Tomatoes. There we go. The order doesn't matter. Well, for some of you it might matter, in which case I suppose you use peas. All right. Anyway, for the next type of probability, I would like to explore the tree. Behold the tree. I'm not going to make you make one. I'm going to do the making. This is boy, girl. This is boy, girl again. And boy, girl. And let's say that for some weird reason, these scientists have figured out some potion that you can drink to make it more likely that you will get a girl or a boy. And they've got it dialed in well enough so that if you drink this certain potion, there's an 80-20 chance that you will have a boy. Okay? Could be the other way, because again, would you agree that for families that already have two boys, would really like a girl, they'd pay a fair amount of money for a potion they could drink that would make sure that their next child was likely a girl. See what I'm saying? Because a lot of people want to pick that last kid. Maybe they don't care about the first one or the second one, but if they're only going to have two, they might want one of each, or we've already got two boys. Like to have a girl. All right. So, again, there's no reason it has to be 80 boy. It could be 80 girl. If that's bothering you, I will change it. So we'll go 20 boy, 80 girl. All right. It is, but the argument is often that boys get priority in this society, and so I don't want to be that guy. So, all right. Anyway, would you agree that this one adds up to 2 times 2 makes 4, 0.04? If you drink this potion twice, there's only a 4% chance that you would have two boys. Does that make sense? That's boy, boy. Then, this one was boy, then girl, and it was what percent chance? 8 times 2 makes 16. Okay. This next one's also a 16% chance to be girl, boy, but then the big one is 8 is 64% chance that you would have girl, girl. Okay. Now, given that chart, here's a complicated math question about it. Oh, first a question.
Is 0.04 not 0.4?
Yeah, because 0.4 would mean 40%. Now think about it. These all have to add up to 100. And if that was 40% all by itself, it would be way too big. I know you're thinking 2 times 2 is 4. You're right, but there's 2 decimal places in each of these. And when you have 2 decimal places in each of those, you have to factor that in. All right, anyway, so it's 0.04. So now, here's my question about it that's one of the more complicated ones. Easy one would be like, what's the probability of boy, girl? It'd be like 16%. You might have a few easy ones like that, but here's a harder kind. Probability given, we know, because we had some insider information that they did get a boy. We don't know which child was a boy, but one of them at least was a boy. But we didn't hear the name of the other one, so we couldn't tell if it was a boy or a girl for the other one. But we know there was at least one boy. What's the probability that it was 2 boys? Given there's at least one boy, what's the probability of boy, boy? If you aren't dividing something right now, you're not doing it right. So I didn't say the first child was a boy. I said one of them was a boy. Given one of them is a boy, do you agree these are the only things possible? So we add those up, or we say not this. You remember how not that works? Not 0.64, and that means 0.36. That's what these do add up to. Okay, so 36 goes where? That's what's possible, and that goes on the bottom. Good, and then what you wanted was boy, boy. So 0.04 out of 0.36. Raise your hand if you had that one right. Good. Okay. Now you could just reduce this and go, it's like 4 out of 36, which is like 1 out of 9. So there's a 1 in 9 chance, which is about an 11% chance. You could actually do this one in your head. I was wrong, but pretty tough to do without. Well, once you get it set up, it's really not that tough to do. All right, so let's try one more hard one with a tree. Let's do expected value. Okay, now in this case, the goal, if they're drinking this potion, what's the goal in their mind? To get a girl. They really get, maybe they already got 3 kids and they got 3 boys and they want a girl now. So then what's the expected value of number of girls? Well, expected value is always probability times the amount. We already know all the probabilities. Now you have to multiply by an amount. Expected value of the number of girls. So then your probabilities are there. That's easy. What's the value? No, sorry, I shouldn't say that. What's the amount of girls here? So you'd multiply that number by 2. What's the amount of girls here? Amount of girls here. Amount of girls here. And 0 times anything makes it just cancel off, so we just have to do that times that times that, and that times that, and then what do I do to them? Add them all up. Good. Somebody got the answer already? What is it? 1.6. The expected number of girls, then the expected, and remember, is that how many girls you're probably going to get? No, you're not going to get 1.6 girls. You're going to either get 1 or 2, but that's an average. Okay, so that's expected value. Another expected value kind of question is if you're doing warranties. Like for instance, I'm going to buy a warranty to insure my fish. Okay, so you can buy a warranty for pretty much anything. Try it on Amazon. You buy something, they'll offer you like, you can buy an extended warranty on this. I guarantee you can probably buy an expected or a warranty on a fish. All right, so and there's probably places like pet shops that'll sell you like, you know, if your fish dies, we'll replace it for you within. There you go. Yeah. Okay, so here's my warranty question. Let's say that this fish on my wall back there new was going to cost 250 bucks. They do cost a lot. They really do. I got that one at a garage sale, so it's only 10 bucks. But you hire a taxidermist to stuff your fish, it's going to cost a lot of dough. Okay, so I got a $250 thing. Let's say that the warranty on it costs 10 bucks. And it'll replace the fish if it breaks, but the probability of that fish breaking is pretty small. I mean, unless you have people playing with the fish or whatever, it's not likely to break. So let's say there's only a 1% chance that it will break. Then my question would be, if that $10 warranty will give you the value of the fish, if it breaks, it'll give you your 250 bucks back, then what's your expected value for buying the warranty? You'd be amazed. I'm telling you, try it sometime. Just call up a taxidermist and say, I got this really big bass. It's like 12 pounds. Okay, that'd be enormous, but okay, let's say it's 5 pounds, and I want to have it stuffed. You'll be amazed. It's really expensive. They'll offer you, I can make one that's made basically, it's basically like a model of a bass that they can make the dimensions the same as your dimensions are. So the cool part about that is you can actually measure your fish really carefully and then just let it go. And then you can bring the measurements to the guy and he'll just make you one that'll look just like the one you had. And you get to feel good about how you let your bass go. And he's still in the lake somewhere, but here's my replica I put on the wall. I think that's kind of a cool way to go. But sometimes you catch the fish and sadly they just are too dead to let go. Like they got hurt so bad in the battle, or maybe they swallowed the hook or whatever. You don't have a choice. Now you're going to mount the actual fish. Again, they can mount it for you, but it is not cheap. Yeah, think about it. The guy has to probably take 5 or 6 hours to do the work. And nobody works for free. You know, standard wage for working out there, even minimum wage nowadays is, you know, getting up. So we'd have probably at least 50 bucks in labor, and that nobody works for minimum wage on that kind of a job. So, all right. And there's some expenses. They have to actually pay for some stuff. They don't use the fish's real eyeballs. All I can tell you is I've seen a lot of walleyes, and if that's a fake one, I'm very impressed. I think that's a real one. And the eye is the part that I was saying that's fake. That's a marble that looks a lot like a walleye eye, but Yeah, they do a great job of the thing I think is much creepier, and it's kind of funny that we think it's creepier, but some people take their cats and have them freeze dried. They usually don't stuff them, but they freeze dry them. And so I don't know, you put them out on the mantle or something, and it looks like your cat that was always, like looked like that, and people do it. No, once you freeze dry them, they're like a piece of styrofoam or something. So, all right. On that happy note, okay. Would you agree that there is a 99% chance your fish is going to continue to work and a 0.1 chance it's going to break? That's the probability. Then you multiply by the amount you get if it happens. My way of doing this is to say, bring the thing to the place and see what happens. If you bring your working fish to them and say, give me money, they'll be like, you're getting nothing. Your fish still works. But if my fish is broken, I bring it to them, they give me how much? $250. Now, I agree that we have to factor in the cost of the $10 warranty, but that'll happen later. I like doing it this way because I get to multiply by 0. That times 0 makes it 0. And that times that is the only thing I have to do. And since I made the numbers nice, I can do it in my head. It's $2.50. So when I take the P times the A, then I'm supposed to not divide, add. P times A, then add. I add these together, I get 250. That's what it's worth. But then I subtract what I paid, and those capitalists, they're trying to make me lose money. If your expected value is negative 750, I think there's nothing wrong with that, because that means their expected value is they'll make 750. They're trying to make money. That's what people do when they sell you stuff. So, moral of the story, this expected value was negative 750. I would have, if I had asked for the fair price of it, I would have said the fair price would have been 250. Now again, you can argue that's not really fair, because then the company is going to make nothing, and why would they want to do that? They're not going to try to sell you something that they make nothing on. So anyway, this would be what you'd like to pay for it, I guess you could say it that way. And this would be your expected value of actually paying $10. You would, on average, lose $7.50. All right. The reason you aren't losing even more is that it was fairly cheap. Most of these warranties out there are way more than $10. Yes, sir.
What about life
Life insurance?
Yeah.
Okay.
Like when you get it for lifetime warranty.
Oh, a lifetime warranty?
Can you calculate that?
This actually can be for a lifetime warranty. There's no reason that this has to be. The thing you have to know then, though, is trickier. You have to know the probability through a whole lifetime that the thing's going to break.
Okay.
And there are companies that make lifetime warranted stuff. And it's usually stuff that's really hard to break. Like, they aren't going to give you a lifetime warranty on a backpack. I mean, because they just wear out. They're gonna. But they can give you a lifetime warranty on, I don't know, some steel ball or something. There's no way to break the thing. So then the probability of it breaking is really, really low. All right. So let's go to a different kind of probability. Last one we're going to talk about is if you have a card question and they just say, what's the probability of drawing a 7 out of the deck of 52 cards? And then what's the probability of drawing another 7? For probability of drawing a 7, and you keep the first 7 out. This is important. And now you reach in and draw out another 7. What's the probability of that? That's called a dependent probability, because it depends on the probability of the first one. So probability of drawing a 7 is easy. How many of them are there in the deck? 4 out of 52. And you times that by, because there's only 3 of them left, out of how many cards left? 51. Very good. That's it. So it'd be 12 out of 51 times 52, whatever that is. Very low probability. And you know, randomly reaching in and getting a 7 is not likely. And then getting another one, really not likely. So that's why it's such a low probability. Okay, there are more kinds of probability, but you don't want me talking all hour, and it's still not finishing all of probability. So let me tell you what you're doing for the next couple days. Remember that blue packet that I gave you yesterday? Your assignment is to do the first 20 problems as homework tonight. Okay, so you can start that in class right now. The blue packet, the first 20 questions. One of them is about expected value. And, sorry, no, it's not. It's about long run value. I want to remind you about that real quick because otherwise I bet it'll stump you. The long run value is where you have this kind of thing. Let's say it was like that. And they say, what's the long run value of it? The easiest way to see the long run is put the thing in your calculator and look at like U sub 100. Go out in the long run, like 100 spots later, and see what it's at. And if it isn't changing anymore and it's pretty much zeroed in at 125 or whatever, that's the easy way. But what if there's no calcs allowed on this section and they say, what's the long run? I'll show you how to do that. These two are a term and the term right in front of it. In the long run, aren't those supposed to be about the same? That's the point of a long run value. And therefore you call each of them x. You could have called them n or whatever. X equals x times 1.05, which let's just do that, because 1 plus 0.05 is 1.05, minus 200. If you can solve this equation, then you have it. Everybody try to solve that one that's on the board. You can use a calculator. Hint, I'd start by subtracting the smaller 1x or 1.05x, whichever is smaller. That's what I'd subtract first. Just do it quick and see if you get the right answer. Use a calculator. Pro tip, 1 is smaller than 1.05. So you should have subtracted 1x from both sides. This is 0 equals 1.05 minus 1x is 0.05x. And how do I solve it from there, Miss V? Yep. And these cancel. And 250 equals 0.05x. And then? Oh, 200, not 250. My bad. This is supposed to be 200s. Sorry. So 200, I'm adding to both sides. And then I have 200 here. There we go. Okay, now we divide by 0.05. And it's like saying I have 200 and how many nickels are in 200. It's a big amount. What? 4000? All right. So my long run value is 4,000. If you had taken a calculator and typed that into your, and with, by the way, this is one of the weird things. It doesn't matter what your starting amount is, because in the long run, it doesn't matter how much you start with. If you keep growing by this much, that's the thing that really matters. And what your percent of growth is, like 5% growth. If you're having 5% growth, but taking $200 away every year or every month or whatever you're doing it in, then that's what matters, not your starting value. Anyway, if you've gone way out in the calculator to like use of 5,000, it'll be 400 or 4,000. So this is the by hand way where you set these two parts equal to x and solve. That's the moral of the story. Okay, so on your packet there, that blue packet, you're assigned 1 through 20, and you're going to be finishing that packet by Monday. So tomorrow in class, you have all day, the entire hour, to work on this packet. Then the homework for the weekend is whatever you still haven't finished is due Monday. The reason I have to have it done on Monday is so that we can give you a chance on Monday during class to ask questions. Like, I didn't get number 14 in the packet, and I will have posted answers. Did you hear that part? The answers will be posted, so you'll have had a chance to already look at questions. And I'm hoping you're going to look at the key first and go, I don't get number 17. I'm going to look at the key. okay, I get it now. Or maybe I still don't get it. The ones where you still don't get it after looking at the key, that's what you ask me on Monday. Okay, so that's what the next few days are going to look like. Tomorrow I have a sub, and let's see. So I guess all you need to know is that you're going to, the same exact packet, you're going to work on all hour, and you may work with other people. That would be smart. And I think what I'm going to do is post the answers for this starting, I'm debating on exactly when, but I will guarantee you this, over the weekend for sure, I will post the answers. So you can check this before you have to hand it in on Monday. And I'll also tell you I'm very likely to put this one in the grade book because it's the last one, and it gives me the feeling for whether or not when a person bombs the final, if they worked really hard to study for it, I'm more likely to give them a break on that than if somebody doesn't do their review. I don't have as much mercy. Of course you're going to not do well on the final. I'm not surprised, and you deserve that grade. You know what I mean? So factor that in, get your homework done, and I'm going to have you hand this sucker in on Monday. Okay, that's all I have for you for today.